Okay, now we want to introduce the center of mass, which is closely related to the momentum conservation. Okay. Center of mass is a point which you can think that all of the system's mass is concentrated there, and all external forces are applied there. In fact, even we didn't actually introduce the terminology. We have already used the center of mass before. Remember that when we analyze the system, okay, an object, the object is actually like some box, okay, it has some volume, but we don't really think about this way. We just think that all the forces acted on the center of the box, okay, like gravitational force, normal force. Precisely speaking, normal force is here, not here. But you can always like draw all the forces at the center, and also you think all the masses are concentrated at this point. So basically, we think about there is no volume related to it, there is no internal structure related to it. So you can squeeze the whole object into one point. Okay, so that's the center of mass. And we can do that because usually, for most of the system, the motion of the whole system can be represented by one point, right? Especially if you think about this is a rigid body. So all the points, like this point, moving in the same way as this point. So this is the represent for all the points. Okay. And but for more complicated situation, the center of mass may be tricky. Okay. We want to use one point to represent the whole object. So naturally, we may think that this point is always located inside of this object, but in fact it's not. The center of mass may be located outside of the body. We can think about if you have some ring-shaped stuff like this, okay? Where is the center of mass? It's in the center here, right? Okay, from the symmetry you can see this is the center of mass, COM, but it's located outside of the object. Okay. Another situation is like this. If you have this kind of shape, okay, it's possible that the center of mass be located somewhere here, right? Okay, it may not be here due to the length of this object. Okay, so this is the center of mass for this object. So it can be located outside of the object. Another thing is we always talk about the center of gravity. Okay. Center of gravity and center of mass, they can be the same or different points on the object. Okay. If the gravitational constant, because okay, you know that W, the center of weight is you can try to concentrate the weight force of the whole object into one point. So you are trying to look at where is the average action point for all the weight. Okay, but weight is different with mass by a constant, by G. Okay, in your case, G is a constant throughout the whole body. So you can think about center of mass and center of gravity as the same point. But if G is different throughout the whole body, you probably need, they may be different. Okay. Usually, for the most of the object we are starting, we think about center of mass and center of gravity at the same point. Because we started some small object, so G is actually constant for everywhere in this object. Okay. Any question here? So basically what I'm saying is that, like, think about if this is Earth. If you have a small object, of course, the center of mass is here and the center of gravity is also at the center. But think about if you have a very large object, okay, like this, very large compared to the Earth. So the center of mass is still here, right? Okay. It has nothing to do with G. But the center of force may be different. You can see because this part, the G is actually smaller than G here, right? Because it's more far away from the Earth if it's a very large object. So maybe at this point it's almost 9.8, but at this point maybe just 8.8. Okay. So you can say the lower part and upper part, they have the same mass, but the lower part receives more gravitational force, or they have a larger weight for the lower part. So you can think about the center of gravity in this case should be move upward or move downward from the center of mass. In this case, it's up. The center of mass is either here or here. The center of gravity is here or here. Here. Because this part, you have more weight. This part, you have less weight, right? So the center of gravity should be more close to the heavier end. Okay? So you can think about this is if you have a very large object, the different part may have different weight. Okay, due to the difference between G at different points. Okay, if you have a very small object here, so of course it doesn't really matter. Any question here? Okay. Okay, now another thing is let's try to think about center of geometry. Okay, so center of mass, center of gravity, and center of geometry. For the center of geometry, usually again it's the same as the center of mass. But this time, again, you can think about it depends on the density distribution. If the density is the same everywhere, so of course the center of geometry should be the same as center of mass, right? Okay. But if the density is different, like if you have two parts, like this part is iron, they have the same shape. This part is, let's say, wood. Of course, the center of geometry is here. But center of mass should be somewhere here. Okay. So, again, the center of mass and center of geometry depends on each other. Okay, so run of power. Let's go back to use the computer. So we use this so we can do the simulation. I forgot to bring my laptop. Okay, so we can do it next time. Okay. Now let's look at. We roughly understand the center of mass is somewhere you average all the masses into one place. Okay. So for uniform object, it's just a center of geometry. But if it's not a uniform object, and one side you have more mass, another side you have less mass, so it may be more close to here. So how can precisely calculate the center of mass? This is the equation. Okay. The center of mass, the location of the center of mass is determined like this. This is just in fact the average. If you have, you can think about you have many particles. Let's say you have several particles, R1, okay. This is R1, the position vector. This is R2. This is R3. This is the origin. Okay, this is origin. Then the position can be written as this. The center of mass position R, COM, equals to the summation of the three vectors. So R1, R2, R3. But of course, different points, they may have different mass, M1, M2, F3. So when you add them together, you need to think about the probability weight for each of them. So should be M1, R1, M2, R2, M3, R3. And then, so you add them with the mass as proportional weight. Okay. And divided by the total mass, M1 plus M2 plus M3, capital F. Okay. So if you have three particles, that's how you calculate the position of center of mass. And by the way, this is a vector expression. So actually, you need to write this down along into x direction, y direction, z direction. So basically, for this equation, you are going to write down like R. So x direction COM equals to M1 x1 plus M2 x2 plus M3 x3. And this divided by M1 plus M2 plus M3. Okay? And y position of the center of mass should be M1 y1 plus M2 y2 plus M3 y3 divided by M1 plus M2 plus M3. Similarly, z position of the center of mass is M1 z1 plus M2 z2 plus M3 z3 divided by M1 plus M2 plus M3. Okay.
Will you be giving us these equations on the formula chart for the exam, or will we be required to memorize them?
No, I don't remember if it's on the formation. No, I think it's not, because basically this is just the average. Can you see that? But not simple average like this, not x1 plus x2 plus x3 divided by 3. Because they may have different mass, so when you average them, it's weighted average. Okay, the weight is proportional to the mass. So you have to M1, M2, M3 divided by total mass. Right? Okay. So this is something you have to figure out. Like if I give you three particles with mass and x position, y position, z position, Okay, you need should calculate the center of mass. Okay, the x, y, z position. Any question here? This one you have to understand or memorize it. Any question? Okay. But you can just think about your average altitude. It's basically the average, right? Now, another thing is that once you the basic purpose to introduce the center of mass is that now for the whole object of several particles, you can think about all the effect is that all the result is that you have one point where all the mass is concentrated there. So you can apply when you do the force analysis, you can move all the forces into that position and apply Newton's second law to there. So F net equals to the total mass, okay, the summation of all the masses, and the acceleration of the center of mass. Okay. So that's center of mass. Any question here?